So welcome again. In the previous lecture, we defined what we mean by a system of linear equations. Then we also gave some examples on systems of linear equations. We also defined what we mean by a solution to a system of linear equations. And so in this lecture, we are going to give examples of systems of linear equations and how we can solve them, and also give a general theorem on the nature of solutions of any given system of linear equations. So we'll start by an appetizer. So show that for arbitrary values, of S and T, so x1 given by T minus S plus 1, x2 given by T plus S plus 2, and x3 given by S and x4 given by T is a solution to the system x1 minus 2x2 plus 3x3 plus x4 equals to minus 3, and 2x1 minus x2 plus 3x3 minus x4 gives us 0. So this equation show that for arbitrary values of S and T, the solution to the system x1 minus 2x2 plus 3x3 plus x4 equals to minus 3, and 2x1 minus x2 plus 3x3 minus x4 equals to 0 is x1 is T minus S plus 1, x2 is T plus S plus 2, and x3 is S and x4 is T. Now, if you remember how we defined in the previous lecture a solution to a system of linear equations, we say that it's a set of values x1 equals to s1, x2 equals to s2, x3 equals to s3 up to xn equals to sn, which when you substitute into the system of equations or system of linear equations that you have, then every equation is satisfied or every equation holds. So if you are given this one, so what simply means is that you have to replace what x1, x2, x3, and x4 are given in terms of S and T into the left-hand side of each of these two equations in this system, and say that after simplification, the answer you get on the left-hand side agrees with what is given on the right-hand side. So our solution or the proof. So proof. So we simply replace the values given for x1, x2, x3, and x4 in each of the equation and simplify to show that the resulting solutions, resulting values agrees with the right-hand side. So that's simple as that. So that is, i.e., for the first equation, x1 is given by t minus s plus 1, and then minus 2. X2 is given by t plus s plus 2, and then plus 3. X3 is given by s plus x4 is given by t. So so we have to reduce this one to show that the answer will be minus 3. You see that this will be the same as t minus s plus 1 minus 2t minus 2s minus 4 plus 3s plus t. And then the next step, we collect like terms. So we have t minus 2t plus t, and then minus s minus 2s plus 3s plus 1 minus 4. When you collect like terms, that's what you get. And then you see t, so this is the same as t plus t minus 2t minus, can say plus 3s minus s minus 2s plus 1 minus 4 is s minus 3. And then 2, this will be 2t minus 2t, and then plus 3s minus s is 2s minus 2s minus 3. So this will give us 0. This will also give us 0. And then this will be minus 3. So 0 plus 0 plus minus 3 is just minus 3. And this was what was given as the right-hand side for question 1. So that is fine. And then in the second equation, so just still replace the same values of x1, x2. And so we'll have 2 into x1 is t minus s plus 1. And then minus x2 is given by t plus s plus 2. And then plus 3x3, x3 is given by s. And then minus x4, and x4 is t. So this is equals to, when you simplify, you have 2t minus 2s plus 2 minus t minus s minus 2 plus 3s minus t, opening the brackets. And then this will also be the same as collect like terms, 2t minus t minus t minus 2s plus 3s minus s, and then plus 2 minus 2. And then this will be 2t minus 2t. And then we have plus 3s minus s minus 2s. This will be plus 0 because this 2 plus 2 minus 2 is 0. And then this will be 0. 3s minus s minus 2s is also 0. And then plus 0, which is 0. And this is also the right-hand side of the second equation. So therefore, that's values of x1, x2, and x3, and x4 holds in the two equations given. So then we just say because both equations are satisfied, then x1 equals to t minus s plus 1, x2 equals to t plus s plus 2, x3 equals to s and x4 equals to t is a solution set for the given system. So that is how we simply prove that a given set is a solution to a given system. It's very easy. Just replace the values given in each of the equations and try to simplify to show that the simplification on the left-hand side agrees with the values given for each equation on the right-hand side. So in this, from this example, so you say from the appetizer above, or from the example above, the values or the letters S and T are called parameters. So the values of X, T, and S are called parameters. And when the solution to a system of linear equations is given in terms of parameters, we say that the solution is in parametric form. Parametric form. The solution is in parametric form. And so simply a parameter is a letter that can take on different values of real numbers, in an expression. Say equation. So the question now will be, how do you find the parametric form of a solution to a given system of linear equations? So let's do another appetizer. Appetizer number 2. So appetizers are simple examples. So appetizer 2, say, describe the solutions, describe all the solutions to the following equations in parametric form. Now, sometimes the equation can just be solve the following equations, not necessarily putting in the aspect of describe all the solutions or put the solutions in parametric form. So let's start with the easiest one, like what we did in the first lecture. So A, if you are given, say, x plus 2y equals to 3. So it's like somebody can ask you, solve the equation x plus 2y equals to 3. So there are two ways. You either express x in terms of y, and then you fix y to be any given parameter that can take on different real numbers, or you make y the subject and take x to be a given parameter that can take on different values of real numbers. All of them will be accepted. So solution. So you say, so first way you can say x equals to 3 minus 2y. So here we have made x the subject. And then once you have made x the subject, then you make this other variable the parameter. And then you say, let y be given by t, where t is any real number. So this t is what you are calling the parameter. And then now when you say y equals to t, then from what you have said, x equals to 3 minus 2y, then this implies that x will be 3 minus 2t, because the y is t. So therefore, the solution is x equals to 3 minus 2t, and y is t. So where t is a real number. So this is the solution to that given system, that given equation. Or if you don't want, you can as well make y the subject and say 2y from what we have in this equation will be given by 3 minus x. 3 minus x, which means that y alone will be 3 over 2 minus a half x. So with this, then you let x to be s. So where I say this s is just a parameter, which is a real number. And then this means that now y will be 3 over 2 minus a half s. And so therefore, the solution is, or the solution set is x equals to s and y equals to 3 over 2 minus a half s, where s is any real number. So this is the solution. And you see from this one here, assuming if you can actually pick any real number for s and to get a specific value for solution of the equation. Like for the case in this one, if I say s to be, I say s to be 0, then x will be 0 and y will be 3 over 2. And if you replace that one into the equation, so 3 over 2 and then 0 here, I still get right and left hand side to be 3, which is the same value on the right hand side. Or if you say I pick, say s to be 2, then x will be given by 2 and then y will be given by, so when I put 2 here, then I'll have 3 over 2 minus 1, which is a half. And so where there's x, I put 2. So I have 2, a half of 2 is 1. So 2 plus 1 is 3. So still okay. So this is another possibility. So this is one possibility, another possibility. There are many of them. So s can take on different values. Similarly, what we got in the first case, if I say I take t to be 0, then x will be 3 and y will be 0. And when you replace here, x3, y0, the right hand side is satisfied. If I replace, I take, say, 8t, this is what for t equals to 0. If I say t equals to 1, then x will be 1 cos 3 minus 2, and then y will be 1. So replacing 1 plus 2 times 1, which is 1 plus 2, which is 3. So this is okay. So there are several values you can take. So either you can take this, you can do it this way, or you can do it this other way. You don't have to do both of them, but this is just to show that there are different ways of expressing the answers. And so from this first appetizer, you can clearly see that what you decide to make the subject and what you fix to be the parameter results into a different structure of solution. Because as you check this one here and this other one here, the structures are different, but all of them are solutions to the same equation. So that shouldn't worry you if you have done the correct thing. So the structures are different, but they have the same interpretation. Now, once you go to the specifics by replacing the values you are taking as your parameters. And then B, I have 3x minus y plus 2z equals to 6. So this is another equation. So you are asked to solve this one. So there are two, because we have 3 variables here, there are 3 different ways of doing it. You can actually fix x or fix y or fix z, and then you'll get different sets of solutions, but all of them will be correct. So first way you can say, if I fix x, I'll have 3x equals to 6 plus y minus 2z. So which means that x equals to, you divide through by 3, so I'll have 2 plus a third minus 2 over 3 z. And now because the right hand side has 2 variables, so you'll have to fix them to be different parameters. So you can say let y to be s and z to be t. So remember, what you are taking to be parameters will be different letters from what you is given in the question, so that you don't have you don't mix the variables given and the parameters. So pick different letters to represent the parameters. So where s and t, all of them are real numbers. So we'll have x equals to 2 plus a third s minus 2 over 3 t. Because we have already known what y is and what z is. So that means that now our solution will be so therefore the solution is, so x equals to 2 plus a third s minus 2 over 3 t, y equals to s, and z equals to t. So this is a solution set. And then you remember to specify that s and t are real numbers. So that is one way. Or if you don't want to subject x, you can subject y. So you can say, or I can decide now to say that the equation was 3x minus y plus 2z equals to 6. So instead of subjecting x, I subject y. So if I take it to the right-hand side, I'll have y equals to 3x plus 2z and then minus 6. So this one now we fix x and z to be different parameters. So you say let x say to be p and z to be say q, where p and q are real parameters or real numbers. So therefore the solution, because now before you conclude the solution, then express y in terms of p and q. So this means that y will be 3p plus 2q minus 6. So therefore the solution is x equals to p, y equals to 3p plus 2q minus 6, and then z equals to q. So this will be a solution set. And don't forget to specify that p and q are your parameters, which are real numbers. So that is how you express your solution. Or you can say that now, I don't want to make x or y the subject, but let me make z. So, or say we had 3x minus y plus 2z equals to 6. So instead of making x or y the subject, let's make z the subject. So we have 2z equals to 6 minus 3x plus y. So this means that z equals to divide through by 2. So we'll have 3 minus 3 over 2x plus a half y. Now you fix x and y to be different parameters. So let x say to be r and y to be say s, where r and s are real numbers. So this means that z will be given by 3 minus 3 over 2 r, and then plus a half y is s. So therefore the solution set is, so x is r, y is s, and then z is 3 minus 3 over 2 r plus a half s. So that is what we have. And remember to specify that r and s are real numbers. And then last appetizer C, if we have now 3x plus 2y minus z equals to 3. We are asked to solve this equation. Then there are 3 different ways. So first thing is to say, let's make x the subject. So I have x equals to 3 minus 2y minus plus z. So which means that x equals to 1 because I'm dividing through by 3 minus 2 over 3y plus 1 over 3z. So then I let y to be s and z to be t, where where s and t are real numbers. S and t are real numbers. So this means that x will be 1 minus 2 over 3 s plus a third t. And so therefore the solution is x equals to 1 minus 2 over 3 s plus 1 over 3 t, and then y is s, and then z is t. So this is a solution set. And remember to specify that s and t are real numbers. Or you can as well make z the subject, y the subject, or say let make y the subject, so that we have the equation was 3x plus 2y minus z equals to 3. So we'll have 2y equals to 3 minus 3x plus z. So y equals to 3 over 2 minus 3 over 2x plus half z. And so if we let x to be, say, k, and z to be, say, L, where k and L are real parameters or real numbers, then this means y equals to 3 over 2 minus 3 over 2k plus a half L. So the solution set will be x equals to k, y equals to 3 over 2 minus 3 over 2k plus a half L. And then z equals to L. So this is a solution set. And remember, k and L are real numbers. Or you can make Z the subject. So say we had 3x plus 2y minus z equals to 3. So this means that z will be 3x plus 2y minus 3. So let x say to be p and y to be q, where p and q are real numbers. So this means that z will be 3p plus 2q minus 3. So the solution set is x equals to p, y equals to q, and z equals to 3p plus 2q minus 3, where p and q are real numbers. So let's now do the remaining bit on nature of solutions of systems of linear equation in the next lecture. So thank you.